Hello students, practice problems 4.3 today. Should have already completed these, be checking them. First problem here, number 2, pretty simple little thing. You're just trying to figure out how many electrons and protons are in an atom of each. Now remember, for an atom, number of electrons is equal to number of protons, and we just have to look them up on the periodic table. Arsenic, element number 33, atomic number 33, so that's 33 protons and 33 electrons in each atom. B, we got gold, that's Au, element number 79, so 79 protons in an atom of gold and 79 electrons in an atom of gold. Fluorine, symbols F, atomic number 9, meaning we have 9 protons and 9 electrons in each atom of fluorine. Molybdenum, element number 42, symbol MO. So we have 42 protons and 42 electrons in each atom of molybdenum. Polonium, element number 84, symbol is PO, so 84 electrons, 84 protons in each atom. And one more, barium, Ba, number 56, giving us 56 protons per atom and 56 electrons per atom. And here we want to know the atom containing the following number of electrons. So this would be the number of electrons, also the number of protons, because we're talking an atom. So we just look up the number in the periodic table. And number 34 is Se, selenium. Number 5, B, boron. C, number 31 is Ga, gallium. '61, we have PM, which is promethium. And 94, we got Pu, and that is plutonium. Now here you could have identified them by their symbols, by their names. It just says identify them, either would have worked. I gave you both. Number of protons, again, we're just looking up atomic number. Number A, we got 74. 74 is W, or tungsten. Number 20, Ca, calcium. 49 proton, we got In, indium. 70, YB, which is ytterbium. And 93, we have NP, neptunium. Our periodic table tells us the number of protons per atom of an element. And if it's an atom, it's also going to be the number of electrons. As we move on into ions, that part will change a little bit. 18 protons and 18 electrons. Number 5, another thing, similar thing. So number 18, Ar, argon. Number 7, all naturally occurring atoms of fluorine has a mass number of 19. Determine number of protons, electrons, and neutrons in an atom of fluorine and write the atom's symbol. Okay. So, we've got fluorine. We look on the periodic table and we find that to be number 9. That tells us it has 9 protons. 9 protons, has 9 electrons, and then if its mass number is 19, and we do a 19 minus a 9, we get 10, mass number minus atomic number, so it has 10 neutrons. And then its symbol for this is, we write the mass number up here, and your atomic number down here. Yeah. Lots of stuff on that problem. And describe the subatomic particles comprising an isotope of zirconium-94. So I go to my periodic table and I look up zirconium. Actually, I don't even need to do that because they gave us this. So they told us 94 ZR40, and that's all the information we need. So element number 40 from the periodic table, that's our atomic number, so we have 40 protons, 40 electrons, and if we subtract these two things, it tells us the number of neutrons, and we have 54 neutrons. Number 9, we got a mass number of 112. It has 64 neutrons. Identify the atom, determine the number of electrons and protons. Okay. So if it has 64 neutrons, and we take 112 minus that 64, we got 48. That means it has 48 protons. And it means it's also going to have 48 electrons. And if we look up number 48 on the periodic table, that's CD or cadmium. Number 10, we have 78 electrons. Mass number 198. We want to know number of protons, number of neutrons. Number of protons has to be the same as number of electrons, so it's easy. Number of neutrons, we will take 198 minus the 78, and we get 120 neutrons. And 78 electrons, 78 protons means it's element number 78. It also said to identify it. So element number 78 is, looking at our periodic table, PT, which is platinum. Gallium occurs as a mixture of two isotopes, Ga69, Ga71. Calculate the atomic mass of gallium. Here we want to take the percent abundance times its mass. So they told us we have a 68.926. We want to multiply that by 0.60108. And then we want to do the other one, which was a mass number of 70.925 times 0.39892. So we multiply both of these together and then we'll add them together. And I'll just do all that in one step and one series of calculations on the calculator. So I got 68.926 times 0.60108 plus 70.925 times 0.39892. Hit my equals key, and I got 69.723. And that should be my mass for gallium. And this to check it, if I just go to the periodic table, gallium, number 31, my periodic table I'm looking at says 69.72, so that looks good. Number 12, another one. We do the same thing for germanium this time. This time I'll just go ahead and look at the periodic table and see what germanium is. And germanium, there it is. Wow. Periodic table saying 72.59, so that's where we should end up with. But we want to go through and do all our calculations. And problem like this, you would need to show me the calculations. If you just write down the answer from the periodic table, that's not good enough. So we want to make each of these as a, so that would be actually 0.2123, 0.2726, 0.0773, 0.3594, and 0.0744. And we're going to multiply, 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 and we're going to add all that stuff up. Again, you can run this all through in one series of calculations on your calculator. So I've got 0.2123 times 69.924 plus 0.2766 times 71.922 plus 0.0773 times 72.923 plus 30.3594 times 73.921 plus 0.0744 times 75.921 equals. And I'm going to keep about 3 decimal places on this, and we'll say it's 72.951, matching what I looked up on the periodic table. And chlorine made up of a couple of isotopes. So we're going to do the same thing. I got 75% and 34, so 34.969 times 0.7577. And then we've got 24%, but we don't know this. So it's some x times, get rid of that 2, times 0.2423. And then it wants us to find the atomic mass of Cl37. So we want to find that x value. Yeah, we do all this from our periodic table. I find a value of, for chlorine, 35.453. Now, if I go ahead and multiply these two together, I'm going to write it down here, we've got 34.969 times 0.7, whoops, I just typed there, 34.969 times 34.969 times 0.7577. Now, I got it typed in right. So that gives us 26.496. And then we're going to subtract that off of here, minus 26.496, and that gives us, I miss on the calculator, I've got the 26 on there, I'm just going to subtract 35, and the only difference is it's going to give me a negative value, and I'll just ignore the negative value, and we get 8.957. So that's what this one has to equal, 8.957. Then to find the x, I'm going to want to divide by that. So I'll divide both of them by 0.02423. 0.02423. So I'm going to come down here, write that down again, 0.2423. So we take the 8.957 divided by 0.2423 equals, and I get 36.967. And that would be, I forgot to write, AMUs. There we go. So, a little longer lesson here. Should be able to calculate these average atomic masses, work with them, and you should be able to find the number of protons, electrons, and neutrons. So that's it for now, till we get back together.